Hey guys, welcome to System Design Fight Club. I am doing my predictions for how the content of Alex Shu's upcoming machine learning book should look. I'm going off of just the titles. I haven't seen his actual solutions yet because the book's not even published. In this video, I'll be covering Chapter 8, Ad Click Prediction on Social Platforms. And again, all I had to go off of is the title that he had for the chapter, because that's all he has released in his blog post. And this is my best prediction for how the content should look. These are some resources that I went off of for creating this. Some similar problems that are that'll have some overlap with this is that the way that I covered the video recommendation system chapter has a similar two-step design to what I'll be doing. And then also the personalized newsfeed design has content-based filtering, which is what I'm going to be using for step 2. For the requirements, it's just that users will have relevant ads chosen for displaying to them. And the clicks and user profile info could be used for relevant, could be collected and used for the ads, for targeting the ads. Okay, so call outs, the cold start problem is probably going to be relevant here, this chapter is probably the best opportunity in the book for covering reinforcement learning or the multi-arm bandit problem. I don't know how that works. I don't know how to do reinforcement learning, so I'm not even going to take a shot at it. I really think that the book should have reinforcement learning somewhere, though. It really needs to cover it somewhere. It's beyond me, but if you're going to write a whole book on machine learning system design, I think it has to be in there, and you have to take the effort to do that. I'm making all these videos in a single weekend, so no, I'm not going to cover it. I'm not going to force myself to figure out how to do it just for this video, but I really think it needs to be in there. Social platform was specified in the title as opposed to a regular ad click prediction platform. I think that might be used as a cop-out for avoiding the cold start problem, which is actually pretty important to cover. And so then you would be able to dodge the entire topic of reinforcement learning for handling that cold start problem. It also means that you might be able to drop on the 2 steps that I'll be using. Due to you'll have richer user profiles on a social platform, because you'd be able to do a lot more data collection off of their own user profile and how they've been engaging and interacting with the website, the social platform where the ads are hosted. I'll show you how that's going to work a little bit. I'd be surprised if he actually shows the data collection aspect a little bit and how to do the data preparation for it. So this video is going to go a lot deeper than I imagine his chapter is going to be for this. It's going to be a pretty epic diagram, but I like to go deep and not hand wave away any aspects. That's kind of my point in doing this series is kind of go deep and not do any actual hand waving. And I want to see how much hand waving Alex Shu is going to do. So it's going to be a 2-step model, similarly to video recommendation system. The first one is going to be the candidate generation. Step 2 is going to be the ranking service. So for step 1 in the candidate generation, it's going to be collaborative filtering with a user-based model. It's going to be using the nearest neighbor approach. I forget what the other name was for that. I had it in one of my other videos. Oh, it would be in I did people you may know. I think people you may know also used a user-based collaborative filtering approach. And then it's going to be a classifier. K nearest neighbors is probably a good model for that, for the classification model. For the ranking service, it's going to be a recommender system, and I'm going to be doing content-based filtering for that, which would be similar to what I did for personalized newsfeed. Actually, I think this one was, yeah, I think I said people you may know. I'm pretty sure it's people you may know. And then personalized newsfeed is probably content-based filtering. And you're going to need to use a logistic regression for this. We want to do probability of click-through, not just are they going to click it or not. Other classifiers that are not a regression model are not just going to return the probability. It's just going to return a binary yes or no. Since we want to do actual ranking, that's why you need a regression instead of just a normal classifier there's a lot of other classifiers, but you specifically want to have this nice range in the output. I think an AUC performance measure might be useful here. So that's the data model we'll be using. So now I'm going to go ahead and jump into the diagram. Yeah, let's go ahead and move this over to the side and make sure that you guys can see it while I'm going through the video. There we go. Okay. So we're going to have the browser for a user that's trying to view the page. So it's going to be user requesting a web page. So it's viewing ads. A user that's trying to view some ads. They're loading up their newsfeed or whatever, or requesting their, say for clarity, requesting their news feed. That's what's going on here. Okay, a longer thing, but I want to be really clear on that. Okay, and then there's going to be an ad placement service involved in this. That'll be on the back end, is that we're going to have this ad placement service on the back end, which is going to return the list of ads that they're going to request. I want to, a good follow-up video for this would be combining this design with the ad click aggregator. I'm going to kind of show the high level of how that would look. This design on its own is going to be rather epic, and the one for ad click aggregator was rather large. This is a user clicking an ad. This is the thing that it wants to get you to do. It's going to return ads that it hopes you actually click on. But we're going to have that as the training here. It might actually make a bit more sense to have it as a step 2. Yeah, okay, let's go ahead and have it as step 2 to make things really, really clear. Yeah, and then we're going to have our click capture service. These are some aspects from that ad click aggregator design. I'm going to show you how it ties into this problem. It's the click capture service. Okay, so you're going to do a click. It'll have the user ID, and then it's going to return a list of relevant ads. So you're just going to have your user ID. That's all the context you're going to be giving it. It's the user ID. And then we're going to have our list of relevant ads. Okay, and so when you click in our design, we immediately followed it with a Kafka stream for high availability. Kafka stream. I believe alternative approaches is where there's logging, and then you occasionally stick the logging off into something. So you have the user ID, you do the, whoops, it's not the arrow I want. You click, it goes over here to a stream to capture the information, and it returns. And then, yeah, user ID, it also wants to know the ad that you clicked on. And it should fetch that from, it also needs to get the actual, this is user clicking on an ad. It will be a 30x response coming back. Okay, and we're gonna have some kind of cache or something. I actually forget how I did this in the other design, but it is the, what was it? Did it just have a link already there, and then you just log it before? It might be the ad ID link mapper or something. Okay, so you're going to, and this would be like a Redis cache or something. Go ahead and have that. Okay, so you click, and then it will redirect you to the proper location, but it's going to record it first. So first the click comes in, It's going to record that. It'll get the relevant link, and then it'll send you back a 30x to redirect you to the appropriate place. What we care about are those clicks, though. Those are going to become some training data. And so that's why we're going to have the Click Capture store. I think I named it, actually I had two different databases. One of them was aggregated data. Another one was just the individual clicks. I think we want the individual clicks here. One of the data stores was for individual clicks. And so somehow we were getting those individual clicks all the way into a click capture store, which is probably something like Cassandra. And those are going to be, we're going to use change data capture to get it into our data warehouse, which is where we're going to we want to train the models to predict what you're going to click. And you don't want to do a massive key range query, a full table scan on prod. So we need to do change data capture and move it off somewhere else where we can do those big, gigantic analytical queries. So this one could be a solid arrow. I've actually seen this in prod before, is data getting copied over to a data warehouse. And we did just kind of use DB triggers for that. Yeah, okay. Let's make some more space for ourselves. You know what, I'll just zoom out a little. Yeah, we're gonna need some space here. Okay, so it was a two-step approach is what I had. There was a two-step approach. We're gonna have the candidate generation service, and we're going to have the ranking service. Okay, we can start filling this out now. Well, so these two are going to have a data model. Let's go ahead and mark the data model on each of them. And I think I already said this in here. This one's going to be based on similar users. This one's actually going to be trained specifically on you, just you alone. And it's content-based filtering. I had a similar problem up above in my text file. It's going to be an individual model per user. That is really how you do content-based filtering. Every single user gets their own model. This is how I've seen it described in other sources that I've used. But yeah, this one's going to actually come off of a model store for that. This one is going to be directly deployed like straight onto the service. I'm going to illustrate that a little bit better later in the video for sure, though. And that's why it's going to be so epic, at like large. That's why the design is going to be so large. And so it actually is going to pull it. It has to pull the individual models. And this is going to be a object store. It could be like Python pickle files. So if you do your training in scikit-learn, you can store that model off onto disk with what's called pickle. It's just a easy thing that you can use, and it's just you know, an import thing in Python. And this thing's actually going to have to pull those models in. And that is how you're going to get it. You don't deploy the model directly to the machine. So the other one is also going to have a model store, but it is that's just for version control. This is just for version control. You're going to do, in order to get onto the machine, you would actually run a deployment. It does not dynamically request the model. You actually have to run a deployment of the service, and then it deploys that model along with the executable file running that service. So like your jar file, the same way that you're deploying your jar file, you're also going to have the model store, the model served up with it. Okay. Yeah, let's just kind of move it like that. I'll have it like this. Okay. We're going to need to have flattened stuff for, we're going to do we need to flatten data to features for this one. I'm going to do the feature thing again. So you're going to have a user feature store, and you're also going to have an add feature store. Let's go ahead and fill those in. And then those are also going to be used in the model training. Let's go ahead and fill in the model training workers first, actually, because that one's a little bit more straightforward. Because you're, of course, going to need to train the models in like scikit-learn or something. And then you're going to deploy them off to here. And then that's going to beg the question of where you get the data. Well, okay, so we're also going to need to have a user feature store and an add feature store. And these are also going to be used for training the models for these specific things. I think you might have a data warehouse for, you might have change data capture against a data warehouse that'll copy, because you don't want to do an analytical store against prod, analytical queries directly against prod. I'm just going to combine those to keep things really simple here. But in reality, I think that there should be separate separate copies of the user feature store and the add feature store to make an OLTP version and LDAP in OLAP version. Okay, this will be the user feature store. And then we're going to do an add feature store. The data for these can be just pulled straight off. I'm going to do that at the end, is specify the but you're going to want to see those combined. It's if Alex Shu possibly covers this, he's just going to keep it as a single OLTP database. But in reality, you would, I'm pretty confident you would have these separated. And I definitely want to cover that. So we're going to do this with a simplified version, and then at the end, I'll show the realistic version that has OLAP and OLTP separated. Okay, and so when this would, okay, yeah, this will be context for that data model. Let's go ahead and talk about how these data models are going to work. Yeah. Okay, I can go ahead and do that one next. Okay, so we have the data. Well, you know, I need to talk about the setup of these stores with that little square thing. I'll actually do that one first. Okay, so the rows, users, and then the columns are features. That is how the user feature store works. You might actually flatten this so that you turn the columns into sub rows, kind of, and by sub rows, it's actually a row on its own. I'll do that in something else in a follow-up. But this is usually how it's going to be communicated, though, is that the columns are unflattened or unflat mapped or whatever. And this one would be adds features. Okay, and the user feature store is actually also going to be called, okay, I remember what I did here. Yeah, the user feature store also needs to be used by this. Yeah, and now I can show you how this is all going to map out. So we have a user, they're going to be requesting an ad, or they need to see their ads. They're going to have their user ID come in. That is all you have. It's just like, hey, this is the user that we're going to need to show ads for. And first, we're going to need to generate some candidates. And again, all we have is that user ID that we're passing in from the ad placement service for step 1. And then step 2 is going to be that ranking service over here. So we have the user ID. We need to convert this into a flat mapped set of user features for the data model. Okay, this is a good time to talk about the data model. So it's going to take in user feature vals list, which is what you're going to be training the models against. It's going to spit out a recommended ad, a list of ad IDs. It's going to recommend some ad IDs. Okay, user feature vals, list of ad IDs. And then how are we going to get those user feature vals is from the user feature store, which is for each user, it's their values along these regularized or normalized features. And so that is why you have this user ID, going to make a request over here to user feature store, and then it's going to return back user features. We're going to show how this thing's going to get made also later in the video. Get back user feature vals. And then those get plugged into the data model, and then you get back a list of IDs, and then you're going to return that over to the ad placement service. So you have your list of ad IDs, and now we're going to do ranking. It's just based off of similar users, and it's just kind of like this big bag of IDs. It's not really ordered. It's not, you didn't use a good training model, a good data model to figure out why or which one is the most relevant. It just is like, hey, these ones look relevant. It's just hundreds of ads that seem like they would probably be relevant, not really specific to you though. And we want to find the ones that are most specific to you. And this is when we're going to use our other data model, which is going to rank these. We're going to rank the list of ads. We got this list of ads. Oh, we want it to be, we're going to turn it into, each ad is going to be turned into its feature vals. So it's going to be a list of, nope. Okay, we're going to do a list of ads with feature vals. And so we need to turn those ads, each individual ad like ID into the features associated with that ad. And so that is why we're going to make a request over to here. Oh, okay, that's what just happened when I was typing. Cool. All right, and so we're gonna have a, you probably, okay, yeah, we can go ahead and pass the entire ad IDs, and then it's, instead of doing key value style queries, or we could have, it could be a key value store, and then you just make that many calls to the ad feature store. Either way, they're not that different. I don't want to cover, they're not different enough that I would need to cover this as different approaches. Okay, and then we're going to say list of ad IDs with feature vals. Okay, so now we got our feature vals, and we're going to turn them into a sorted list. Oh, well, it's going to be the score of each ad ID list of we'll look at this in a singular manner. Let's look at this in a singular manner. I think you do actually pass through each ad individually to the data model. Yeah, you do pass in an individual ad. You're going to call the data model one at a time, and it's hosted locally. You pull it in from the model store. You're going to pass in, actually you do need the user ID here too, because of the model store. Okay, because you're going to actually pass the user ID to the model store, and then you're going to get data model for that specific user. And then that is the data model you'll have here, and you're going to run each of those ads against that data model, which is locally hosted now. And then for each individual ad, you're going to get score for that ad. And so now they're all scored, and then you can just sort them by that score. And it's going to be a logistic regression, or yeah, we'll say logistic or linear regression, some type of regression. You need some type of regression for this data model. And then you can sort it, and then you can even filter it by some threshold. And so then you're going to be returning a list. You're going to have that based on that same list. It's now just sorted, sorted, ranked ad IDs. And they're even possibly filtered by some score threshold or count cutoff. So you would maybe just find, so maybe just like the 5 ads with the best score, or just the one that scores the absolute highest. And so then you're going to return back, that is how you get your relevant ads. And so now we have our relevant ads or relevant ad IDs. Okay, so we have that. We have our user feature store. This is a good kind of checkpoint for us. We haven't hooked up the data model yet. We haven't talked about what all data is getting pulled into these. We're going to talk about how our data gets there. I want to talk about how the data gets there. So this is actually going to be the target for the data models, what your target class is when you're doing the training. So we're going to copy it into both, need it for, I'm pretty sure we need it for training both. Yeah, we are going to need it for both. Now I'm going to clarify the target class or column in the data frame for training the data models. It's your target that you're trying to predict. Because this is classification. Whenever you have classification, you're going to need a target like that. Okay. I think I also need to have the user feature store. Yeah, I think we're going to dig into, well, okay. We also need to do feature extraction for the ads. And so you would have, you'd also have a copy of the ad data store somewhere in the data warehouse as well. So this would all just be one centralized data warehouse. And then you have ads table. Well, because you would be doing CDC off of the ads table in order to get a copy of it. And you would need to do a feature extractor worker. This will be a lot more clear what this does when I talk about how it works for the users, for the user table. Feature extractor worker. And it would pull in the data from the data warehouse. It's going to write it over to the ad feature store. It's going to turn each ad into the features that you would actually use for the ad feature store. And at the end, I can separate this into an OLAP copy, which would also kind of be in the data warehouse versus the OLTP copy. This would be the OLAP copy of the ads table. Just say it like that. That's probably the most easy, the best way to communicate this. Okay, and then we're going to have all this user data as well. That should also be in the data warehouse. I'll go ahead and I'll fill in this a little bit better later, but we're going to start off with, we'll have the users DB. We'll have the posts DB. We'll have interactions and engagements. It's also going to use every single like, every single comment to train what your preferences are. These are all going to be put into the data warehouse in some way. We're going to have the data warehouse. We'll just say data warehouse there. And I think, yeah, I could actually just leave this one solid. And so these are all getting copied into the data warehouse. By CDC with DB triggers. I mean, you could use a broker instead on the front end of the database instead of on the way out. And so then it just copied into the DB and then the data warehouse. But then that would make these diagrams like way bigger. Okay, so those are all going into the data warehouse too. It gets a copy of the data, and then you're going to need to also have a feature extractor worker that turns this into meaningful features for your data model to be trained against. And then that is going to go over here because the same features, the same normalized features that you use for training it should also be the ones that you're going to use for the data model. So the same features you train against are what you need in live production. Yeah. So the feature extractor worker is going to pull in all that data from the data warehouse. It's going to turn it into meaningful or simplified usable features for the data model to train with. And then it'll stick those normalized usable features for the data model over into the user feature store. And then here it is getting pulled into the training worker over here. Okay, and then it also needs, it's a classifier, so it needs to be able to, it's predicting something, it's predicting the clicks. So you also need the data for the clicks, which is getting pulled in over here. Yeah, okay, I did already do that part. So the target class is already getting pulled into both. They should also be hooked up to their feature store. I have that. Okay. And so this is just representing similarly to how I have this users DB and it's copied into the data warehouse for OLAP, because you, again, it's this is OLTP. You have a data warehouse copy. So then this is the OLAP edition. We can actually do those massive full table scans and stuff. You don't want to do those against OLTP. So this is a nice extra checkpoint in our diagram so far. And now I want to also dig into the data getting there for a more full copy of what we're doing. So you have the users DB. That's going to come from a user that is updating their profile. So this is just profile update service. We're working backwards here, which is not my usual thing. But in our case, it makes sense since this is very much on the fringe of what people normally cover. And then we're also going to have, so a user is going to be making post. They're also going to be making a post, and you'll have the post service, posting service, where you make your post, then it gets fanned out somewhere. So with this, you're updating your profile. Goes over here, it says 200 OK. Yep, I've stored your update. Turns back that 200 OK. Turns back 200 OK. Asynchronously DB trigger off the write ahead log. And then it's getting copied into the OLAP table. And you're going to do these big massive key range query scans over here to pull in that data for, and then you're going to convert it into something that is understandable by your data model. And then you're going to write it to over here. And then when you're training a new model, you pull in those easily understandable features for the model you're training. You're going to go ahead and train up that data model with the target class, and you're going to write it over here. Okay. So when they're making a post, so these are very simplified views of these much bigger systems, similarly to what I did with the Click Aggregator. What's that over there? There we go. And I guess I can go ahead and use a dotted arrow, although, yeah. So again, simplified view. And then we're going to have user liking a post. Spelling it properly. Still not spelled properly. How did I manage to do that? There we go. User liking a post. And this is the user engagement tracking service. This is it spying on you. Or logging your like, because it should also show it back to you. So all your engagements on the platform, though, on TikTok, it even just watches you. It tracks how much time you spend watching a post, watching a video. So even if you don't watch the entire video, if you don't like it, if you don't like the video and don't click that like button, but you watch the whole thing, it's going to track that, and it's going to use that to determine what ads to show you. So all your engagements, all your interactions on the platform, it's going to log it. Just silently, asynchronously in the background. And it's going to be in these OLTP databases, and we're going to copy those into a data warehouse where we can do those really big key range queries for prepping the data. I think I've covered most of, I wanted to, I should say what type of model I used, what the actual specific model is. Okay, so I did that already with logistic linear regression. This one uses a neighbor-based approach. So KNN, K nearest neighbors classifier should be over here on the first data model. I think I already spelled that out over here. And it's a user-based content, user-based collaborative filtering approach. Okay. So we can, this is like way beyond what Alex is going to have in his book already, but I want to go the extra mile and show you that OLTP OLAP separation again. So I've already kind of illustrated it there. But we can go the extra mile because you're watching System Design Fight Club. What just happened? I don't think I broke anything. Okay, we're gonna go ahead and copy it. And I'm gonna show you that OLTP OLAP separation because this is System Design Fight Club, and we go deep on these things. Over here, got the model store, that's fine. We have the add feature store is what we're going to make a copy of. So copy that, paste it over here. Have the OLAP version. And so it actually builds it in OLAP first. In this specific case, before it copies it over to OLTP. And this could actually be live within the data warehouse. Data warehouse is just a term for this big mashup of OLAP stuff you can use. So we've got that. And then when you're the training is going to pull in a whole bunch of stuff. That is an analytical query. So you don't want to have that there. Haven't seen how it's normally done from OLAP to OLTP because you usually go the other way, but I think DB triggers probably still work fine. And well, you'd maybe do a worker and you would manually be like, yes, it properly did this feature extraction. We're good to do a deployment to prod. So you might just do it as like a worker. You'd probably just use a worker. So it's like a deployment worker. So it's like you might run a deployment of so you might run a deployment of features that are now ready to go in production. I should say deployment workers, deployment worker, sure. And then add feature store. This one has OLTP. And we also want to similarly say OLAP version off in a data warehouse. Wherever I have data warehouse, that is, I have them represented separately, but really it can just be like one big globular service. It's they're not actually they might not necessarily be separate hosting instances like that. It might just be like one big fat S3 bucket. It'd probably be a data lake. When I say data warehouse, it's probably actually a data lake. That would make a lot of sense here, I think. So again, when you're like, yep, these look great, good to go, let's go ahead and deploy them at a comfortable pace to that. And then you would actually do your big fat key range query against the OLAP version of the table. That's an ETL. That's an ETL job. You don't want to do ETL against OLTP. That could even be, that would be a great word to have on these is ETL. Or that would, yeah, for the model training work, I didn't put down the right thing. There it is, ETL. Yeah, so you're definitely not going to see a diagram like this in Alex Shu's book. He's going to abstract away a lot of the details from you guys. We are not going to do that though, because we are System Design Fight Club. If I'm going to make, for the thumbnail, I'm going to have the diagram to the left for sure. That doesn't cover the OLAP stuff, because that stuff is holy shit. But this is a more realistic depiction of production than what I have on the other one. I really don't think anyone would ever go this deep in a real system design interview. Okay. Did I cover everything I want? Let me check the callouts. Cold start. Yep, I didn't cover reinforcement learning. I really want Alex Shu to cover reinforcement learning somewhere in his book. I'm going to be disappointed. You're not seeing me do it because I'm doing this for free. But if someone, is making millions of dollars off their book and they have a book literally titled Machine Learning System Design Interview, I would really like to see reinforcement learning in there. Yeah. Oh, and then I should probably make a follow-up video combining these two designs. That would be really cool. I did that. I did separate the two feature stores. Great. Yeah, and so the first model is not specifically trained against you. That one's really going to have a cold start issue, or this one, yeah, this one's based off similar users and it's a nicer aggregate of clicks. While this one is there's you alone. It's not going to have a lot of data. So that would mean that you would really have a cold start issue there. You would definitely have a cold start issue with that. Because of the lack of data, it's again the explore exploit problem. Then would you only want to show the ads that are that you've clicked on, or should you explore it and try to gather more information about further things that you might also be likely to click on? Because if you've got a data store of literally one click that you're training off of, well, then it's probably missing a large breadth of your actual interests. And so I think it would probably also, that's why you would need to do some exploration and then balancing it. How do you balance exploring with the exploiting the known, the known interests? So that's the whole thing, balancing exploration of interests versus exploiting your known interests. I really hope it's in the book, but we'll see. He might he might hand wave it away because I know it's probably tricky. I think I've covered, a good performance measure for step 2 is area under the curve. Because you want that line to be really straight and diagonal, a really straight diagonal line. It's really good for the ranking service. Yeah. Okay. I think I've covered everything and more than I was expecting to cover in this video. This is probably going to be horrendously long. Thanks for watching, guys. I hope this was what you were looking for. I definitely wanted to go deep with this. I think I did. Thanks for watching. I'll see you guys next time. Thanks.